Hello, great people. Welcome back once again to my page. Today we are going to look at complex numbers, and this is for studies mathematics, or what we call advanced program mathematics. We have a problem here. We were asked to rewrite 2 minus 3i in modulus argument form. Modulus argument form is a complex number notation. Remember, complex number is written as z is equals to a plus b r, where a represents the real part, the real number, and this represents the imaginary part. Now, the imaginary part is the part that has I. Now, how do we write this in modulus argument form? Modulus argument form is telling us to have the value of the modulus, which is the radius, and also have the argument, which is the angle involved between these two numbers. How do we go about this? We use our Cartesian plane to illustrate this. Now, if we draw our Cartesian plane, let's remember that our real part is always on the x-axis, and our imaginary part is always on the y-axis. Now, from the expression, our real parts, they are telling us that x is equals to 2. So x is equals to 2, and from our imaginary, our y is equals to -3. Please make sure that we are using this right value, because the sketch must be in the right quadrant as well. So if we have this in 2's, then it means that our -3 will be somewhere here. So if we have this will be our -3. Please, when you are building, make sure that you build from x. Do not draw this, build from x in the anti-clockwise direction. Now, this forms our triangle. If this forms our triangle, it means that the x value, or the length of the x is 2, and the length of the y is -3, or 3 in the negative section. Now, what is our argument? Our argument is the angle they form between them. That is our argument. What is our modulus? Our modulus is this part, which forms our radius. We call it a radius because if it is under a circle, it is the line drawn from the center of the circle to the circumference. We call it a radius, or we classify it as the modulus. Modulus is the absolute value of z. Now, with that, we can work towards getting our modulus and also getting our argument. Since this forms a right angle triangle, we'll be using 2 things. We'll be looking at using Pythagorean theorem to get the length of the external sides, and for the angles involved, we'll be going into trigonometry and using what we call our SOHCAHTOA. What is SOHCAHTOA? Remember SOHCAHTOA? SOHCAHTOA here is talking about when we are dealing with, now, let's look at this. The side facing the 90-degree angle for every right angle triangle. The side facing the right angle is always our hypotenuse. If we are dealing with this angle, any angle we are dealing with, the length of side facing that angle is the opposite, and this is the adjacent. So the opposite and the adjacent can swap around. If we are dealing with this angle, this becomes the opposite and this becomes the adjacent. So they swap around depending on the angle you are working on. So let's move on. Now we know what O and H is. This opposite hypotenuse, adjacent hypotenuse, opposite and adjacent. And the S, C, and T are the 3 identities of trigonometry, which is the sine, the cos, and the tangent. Now, how do we work around SOHCAHTOA? SOHCAHTOA is when we are dealing with sine, of any angle, we say that it will be opposite over hypotenuse. If we are dealing with cos of any angle, it will be the adjacent from the given triangle over the hypotenuse. If we are dealing with tan of that angle, it will be opposite over the adjacent of that given triangle. Now we have two things to go through. One is getting our argument, and the other is getting our radius. Now let's go through getting our argument. Now, our argument in this case is sine of theta is equals to, we have opposite and adjacent, so we are going to use tan. Opposite and adjacent, so we are going to use tan. So we have tan of theta is opposite, which is 3 over the adjacent, which is 2. Remember that this negative here is used to denote the quadrant where we are. So if this whole angle is 360, then the theta here will be 360, and this angle that is left. So whatever we have here will be 360 minus that, plus that angle. So we have our theta then will be second function of tan of 3 over 2. So our theta, equivalent of theta in this case will be 3 over 2 is 1.5. So second function of theta of tan of 1.5 will give us 56.3. So our argument is 56.3 degrees. So our argument here is 56.3 degrees. Now we have one more thing left. We have gotten our argument, but we need to get our modulus. The modulus is gotten using our pattern because it's the length of a side in that triangle. So our radius, or what we call the modulus, will be, according to Pythagoras theorem, we have the square of the opposite all squared plus the square of the adjacent all squared. So we have here root of 9 plus 4, root of 13. So root of 13 is our modulus. Now they want our expression of this complex number in modulus argument form. Now modulus argument form, the format is the R, or what we call our modulus, into cos of the argument plus I sine of the argument. That is the general form. Now we have to plug in these values that we have calculated. So this in modulus argument form is our modulus, which is root of 13 into cos of theta, which is cos of the argument, 56.3, plus I sine of the argument, which is 56.3. And this is the representation of this in modulus argument form. Please, if you have any question or you need clarity in any place or any section, please ask question. I'm here to support. If there's anything you don't understand how I approached it and you want clarification of that, please don't relent to ask questions. Please remember to share these videos with your friends, subscribe to my channels and follow my pages, and have a blessed day going forward.